So you'll remember that I taught you about how to calculate a percentage error. So you actually delete three values and then you plot, make some predictions, and you look at your percentage error. I think that's a really important skill to understand and embed somewhere in your report, percentage error. You'll need to look at a previous video or talk to a friend about how to do that. What I'm going to look at is a percentage error relative to the very first data value. So this you can see is total beer and total wine. I've got rid of total spirits for this example. I only need, if I'm comparing two time series, I only need two columns of data. So the context of this is if you're comparing two sets of data. So it's going to be relative for beer relative to 3.214 million litres of beer. So that's going to be my first cell, and it's going to be that's going to be 100%. And then my second cell is going to be this value relative to my first value. So 4.3 relative to 3.2. So you take one divided by the other, and to make it a percentage, I'll times by 100. Oops, I forgot to put times in there. Times by 100. 143%. Okay, I don't actually need the decimal places. Let's go 144%. So based between quarter 3 94 and quarter 4 94, the percent increase in sales of beer is a 44% increase. Okay, if the first quarter or third quarter of 94 was 3.2, it's gone up by 44%. That's what that number means. And if I come back up to here and click on the B28, why does it say B28? It's not B28, it should be B2. I think I've accidentally hit the 8 button. It's 36% increase. Sorry. So it's that one divided by that one. But if you come back in here and push F4, it puts those two dollar signs. Can you see that? F4, it puts two dollar signs in there. Now what that does is that when I drag this down, it will always reference the first cell. If I undo that and I forget to put the dollar signs in, push F4, 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 the dollar signs aren't there now, and I drag it down, it doesn't stick to the first cell. It keeps coming down. You want it to keep relative to the first cell. Okay, this has a special name. What I'm actually doing. Anyone know what it's called? It's called indexing. Okay, you may have heard of the Consumer Price Index. Okay, that's a famous type of, or famous index, CPI. And all I've done in this example is I've indexed the percent increase, or in this case, that cell there, look, it's a decrease. 3.1 is lower than 3.2. That's a 98, it's a 2% decrease. So this is index beer. And if I just graph that for you, this is the raw data. But if I graph the beer index, this one, it doesn't actually look too dissimilar if you compare the raw data and the index data. Notice the scales are quite different. This one is obviously in percentages, and as a percentage, whereas this one's still in millions of litres consumed per quarter. But look at the shape of the graph. I'm not surprised that the percentage increase decreases match the same shape. So to do it for one data set, it doesn't make any sense because you've got that shape. You can kind of see it's decreasing. But if you're comparing two data sets, like this is beer and the grey one's wine, it may just help you to distinguish the relativity between the two series. So this one would be index wine, and same thing, the first value is going to be 100%, so 1.5 million litres. The second value, use the equals key, and you go that value, whoops, get in the right cell, that value divided by the original value times 100. And that's a 57% increase just between Q3 and Q4 of 94. Double click on that dot, drags it to the bottom, and just go and check. In fact, before I check, I'll just get rid of the decimal places because they're not really, why aren't they going away? Another way to do it is to come in here and just go number. There we go. So 57% increase. This is a 41% decrease relative, sorry, in wine column. 1.4 relative to 1. No, I've forgotten to push F4, haven't I? Push F4, so it keeps referencing the first column. It's always good to check, check your values. Still 57% increase, but if I double click, that's better. Just check, it's always referenced the first cell. Check again, 96, reference the first cell. So 1.5 relative to 1.5 is almost 100%, or it's about a 4% decrease. Okay, so now here's where it gets maybe slightly interesting. I'll now graph the indexes of beer and the index of wine and compare them. Insert graph. Okay, and that's it. Now they're both relative to their starting points, so it doesn't surprise me that they both start at 100% because that's the starting point. But one is going away from the other, okay, and one's staying relatively the same compared to the other one. Okay, so it's a relativity thing. Where it's really powerful, and oops, undo that, that was a mistake. Where it's really powerful is if you have a series like this one here. This one is your New Zealand arrivals, visitors to New Zealand, and no, it's not. It's the residents who had babies in New Zealand during the year or during the quarter, compared to the visitors to New Zealand who had a baby in New Zealand. See how one's almost a straight line, and you've got no way of comparing one data series to the other. So here's where, and I think if I just click undo a few times, oh, whoops, no, it's not going to work. I'll do it quickly again. This is 100. This is equal to this cell relative to the first cell, F4 times 100, enter, double click, this cell is 100, this cell is equal to 21 relative to 18, F4 times 100 times 100, double click, check my working, make sure it's doing the right thing. Yes, it is. Check that one. Yes, it is. So this is 2 relative. You highlight 3 columns, insert graph. Now we've got something interesting to talk about. 900% or 800% increase relative to the first value for series 2, which is the visitors in New Zealand. So in 2001 to 2003, if you were doing this one, 2001 to 2003, look at these numbers here. Okay, they are 800% increase relative to the very first value. And you may not have picked that up if you just looked at this data set here. Unless you zoomed right into this section here, you may not have picked it up. So that's the power of indexing when you're comparing two graphs and you actually have to have a base number. Or the time series, your base is always your oldest piece of data. It's relative. It doesn't really make sense unless it was possibly the context of weight and you're trying to hit your goal of, I don't know, being 65 kilograms. That might be where you start your indexing, or your 100% might be 65, and you can see how far above 65 or how far below 65 are. You don't always have to have your base number at the start of an index. Okay, so